Hello everyone, I am happy to see you here. My name is Rakovsky Stanislav, and now I will present to you some nice stuff about hunting Trojans in open source using AST transformers and machine learning. I hope my research would be interesting for you. Okay, let's go. So, a bit information about me. I am a malware researcher, in love with Python internals, CTF player, blah blah blah. Experienced speaker, as you can see, a lot of other conferences and other stuff I attended. Before I start, I need to highlight nice information from our colleagues. First of all is standoff cyber battle, and the second one is standoff bug bounty. They are considered by me as extra interesting, so I welcome you to participate. Let's start. First of all, I need to explain you what we will discuss. The first of all, we need to say about the idea behind this research, why we should care about open source security. The second one, we will meet one trouble, obfuscation, so we need to handle it. And the last one, I will give you a small 101 stuff about machine learning to learn a bit more. Open code-based security. We all love open source, and we all use open source. On this slide, you can probably see at least one or two tools that you usually use in your daily stuff. Some of them are written on Python, like TensorFlow, Pandas, OpenCV, Ansible. So we also have some security stuff that could be also recognizable by you, like for example SQL map, Binwalk, Potato. So we have a lot of stuff written in open source, especially in Python, and we need to look more closely in Python stuff. When we use Python, we usually Google some guides about how to use a certain tool. For example, Beautiful Soup. It's an open source Python library that allows you to parse HTML. And we frequently, for third-party tools, face some kind of issue like import errors. And as every one of us, the second action we usually do is trying to install it. But we have a set of libraries that have distinct name, a distinct installation, and import names. For example, Beautiful Soup 4 have import name of BS4, scikit-learn, sklearn, pillow. You probably know about pill. So it can lead some troubles because threat actor can register such kind of names. These names are banned for registering because we are too easy target for threat actors. But sometimes we can face another kind of libraries that could be used by threat actors for these actions. We also need to discuss a bit about how pip works. Pip is a dependency manager, default dependency manager of Python. So here you can see 3 command lines, and each of them have some differences. For example, the second one sets a certain version of library called requests, and the last one sets a mirror where pip, pipx, poetry, etc. will search for this library. Behind every of this work, we have just a simple HTML page, parsable by our human eyes. It's just a set of links. So pip will download this page, crawl through the links, find naming, parsing names and versions, and try to resolve what version is more convenient for your target system, like trying to install requests of the last version of that version of as a part of dependency some certain version. Requests is one of the most popular third-party library, and of course it's likable by some bad guys. So at some point of time you could actually install a bad type of library, a bad version of library, by making some mistakes on a process of typing pip install library name. So, for example, at some point of time, by mistaking the naming of library to request, 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 you could install this stuff. Or you can install by using request naming this obfuscated nonsense. By installing equest, we will be attacked by a Trojan crypto miner called Repka. Or by installing dequest, we could be Trojanized by Trojan downloader. So in Russia we have a phrase, one mistake and you have messed up. Like if you make one small mistake in a pipeline of doing something, everything can be ruined up. Okay, we saw some of the files, some of the projects that were obfuscated. Obfuscation is a tricky thing because it can be used by benign programmers, because there is a natural interest in hiding something like intellectual property. So not every package that we see as obfuscated is actually a malicious one. For trying to understand how to obfuscate and obfuscate code, we need to dive into compiler work stuff for a bit. I wouldn't load you with a lot of compiler stuff, but in Python, you know that Python is not a compilable language but interpretable. But anyway, it has bytecode stage. So for us, the most interesting parts are lexical and syntax analysis. On the stage of lexical analysis, your code would be parsed. You can see 2 lines, hello HITB, and some equation. And as we can see on token table, our code would be parsed to special parts. Like we have names, print a, we have some constants like hello HITB, new line, some numbers. We have some more operators like equal, plus. This token table would be put to syntax analyzer, and after this stage we will have this kind of tree. It can be easily readable by us by walking up to down, left to right. Like we have 2 lines, first of all, is a call of name print with a constant hello HITB, and the second one is assigning to variable called a as a result of binary operation between constants 117 and 10O, and the operator is add. So our compilers will work with this stuff for making your code executable. For example, okay, not all JSON but just JSON, we have a set of imports, and the way looks not so good at all because we are unordered, and so for easing our programming stuff, we can use some tools that will beautify our code. For example, it's a library called isort. What will it do? We can see that our code was not only ordered, but also we have a white line between default library JSON and the third-party libraries like Bini, Fast API, One library, Zero library. So isort knows the way how to work with AST, and it can sort our nodes in the right order. But before that, we thought about only reading AST, and isort somehow modifies it. Let's try to modify our code, our typical example, with printing and assigning. On the language of AST, it would be looked like on the right side. We have a definition of module that has a body with two elements, expression and assign. And you can easily read it and compare to the left side, where the same. Okay, I want to protect this code because I have a precious secret, hello HITB, and I want to hide that I am hello in HITB. So no one cannot realize it before running it. It's just my quirk, I want to protect this stuff. Okay, what can I do? First of all, I can split it to one length strings. It will harden the reading a bit, but for us people, it's clearly understandable that it's a sum of HELLO, white space, HITB, exclamation mark. So this little code will do the stuff that helps us to obfuscate it quite a bit. We can see that it will search for constants with the type of string and the value more than 1. And if it finds it, it will split it to a sum of one-length strings. But we can go deeper. We can actually make this one-like stuff as a set of integers converted by built-in function chr to strings. So for now, we have another transformer that will look for a constant with the type of string and the length of 1, and just cover it with a call of ctr, and will convert our characters to a set of numbers. Our AST for a current stage compared to this one looks even better. But who stops us from going deeper? Okay, we can find these numbers, and if we are a positive one and more than 1, we can just present it as a set of 1 plus 1 plus 1 plus 1. And as we can see, the implementation is also simple. It's just searching for G, searching for constants, and modifying it. the final result looks like this. Of course, we can go even deeper. We can hide these CHR calls to call of built-in global and other stuff. We can also hide print, because it reveals that we are going to print something. But I will stop here, because we are talking about defuscation, not obfuscation. But I need to highlight you that obfuscation stuff is kind of simple. You can easily write your own obfuscator and make such kind of mess. Okay, we have a real-world library called req-sts. Everything looks fine except of last lines. We have exec, base64 default decode, and a line and a long line. So let's look at this in terms of AST. We have a call of attribute base64 base64 decode with some argument. Okay, what we can do with this? We can write a transformer that would look for attribute base64.b64 decode with a constant and try to decode it. So our code will start look like in the top one, like exec of something. In terms of AST, it also looks easy one, like searching for call of name exec with a certain argument as a constant. And yay, we successfully decoded this obfuscated blob, and we have a WASP stealer. It's a famous stealer in PyPI. It would steal your browser credentials, your search history, your Telegram, Discord, etc. So it was an easy one, because we had only 2 calls and a long blob. I prepared to you another stuff. So we would glance at this stuff in more details with examples of defuscation transformers. So, as you can see, it's a real world library, mimicries on a famous library Hyper. We can see Hyper library. So, let's start. First of all, we can see a lot of numbers. For us, it's just an operations between constants. So let's implement some unary and binary math. We can easily use built-in functions for it and just map some nodes of AST to some operations in built-in library called operator. Okay, after this we can see a real-world numbers. Good one. But we have another challenge. We have strange calls of something dot magic function str and subscript of the result of str. In terms of AST, it also looks like just another simple challenge. So this chain, how it can be represented by us? We can see that OCT, hex, and copyright are actually built-in libraries, and we can use it by glancing at their definition in built-ins and what output would come by using magic method str. So we can minus third index of OCT, it's a number C, minus fourth index of hex, it is H, and we have fourth index of copyright there. It could be probably 1, 2, 3 number letter T, probably. not. It could be just a constant string, and we need to keep in mind that we just cannot use built-in function name for calls like str. So at current stage, we can see that these characters C, H, R are actually a built-in function chr. For current stage, we can implement our str magic method transformer that would handle such kind of stuff like looking for calls with str and look for if this value is in built-in scope. If it is, we can safely call the function str because it's built-in function. We cannot just allow us to call every function because some of them could be malware. So we can have some sort of white stuff and try to call as it is. At current stage, we have chr. We can see a sum of it. So we can implement sum of strings as we did it before for dissumming a string, splitting it to a sum of one length characters. Okay, chr. Another stuff, it utter built-ins chr. We can also handle it because built-ins is actually a built-in scope. Another challenge is handling with map. You know that built-in function map will call the first parameter as a function for the set of second parameters. For us, it's a list or tuple. For now, it's a list of just numbers. Okay. We have D, E, S, K, T, O, P. Looks fun. But we need to go a bit deeper. We have a function str.join that would use the first parameter. For now, it's a null line for joining the elements of this list. And at current stage, we can see that all the stuff on the top transformed to the easy stuff understandable by us, OS, path, expand user, desktop. But on current stage, some things could be understandable by us, like usage of APT data, as usage of C program data, blah blah blah, start menu. A small hint of this path, you can put your executable or your script file to this path, and it will be run after restarting your PC. So threat actor or some good guy can put his executable to this path for persistence. Okay, and at the last line we can see some JavaScript code. It's actually a JavaScript clipboard Trojan. I will show the full code of it a bit later. We have some obfuscation of control flow graph. At current stage, we can see on top an initialization of dispatcher. It's a special variable that helps us to go through the cycle on the line 2. We can see that the cycle uses this variable and expects that it would be 0 or not. If 0, it will end the cycle, but our current value is not 0, so the cycle would be run, and we have set of if-elif conditions. We can clearly see that each of these conditions actually checks this dispatcher variable, and if the value matches the current state of dispatcher, it would pass some line. Like for example, here, if we have such value, we would have a run of OS get env app data. So the last line of each condition is a reinitialization of next value for dispatcher. So this kind of obfuscation can be handled, but to implement it, you need nearly 50 or so lines of code, and it would be looked like it. At current stage, we can clearly see opening file, writing to it, closing to it, calculating paths, some stuff that depends on is current user an admin or not. But I will stop you here because you're yawning a lot. But I need to highlight that at current stage, all constants are in a plain text mode, so we can write rules to detect some paths like paths that usually would be used for persistence. The next chapter, kill chains. Every malicious code have a set of actions that it needs to do. For example, for stealers, it could be, first of all, defining targets. This Trojan needs to deal with something. Like, if I need to steal something from browsers, what I need to do is define where files related to browser would be placed. So, for example, here you can see Discord, Opera, Yandex, Google Chrome. The second one, what to do with these files. In common, you can just grab the folder with user profile, zip it, and send to your server. But we have several exceptions. For example, this stuff is not an example. You can see two regular expressions here. They are related to Discord session tokens. By setting it to your browser in a cookie, you can actually enter in someone's session in Discord. And so, stealing Discord session is a common thing for malware engineers, because we can write your friends about, look at this new game, download it and run for running malware further. We can try to mess up with your billing account, with your Nitro, etc. So it's a way of parsing something. For now, we can see just two regular expressions need to handle your Discord account. And the last one, exfiltration. We found browsers, we stole information, but we need to actually distribute it to our server. In this example, we can see that it would be just a HTTP GET request with a parameter of all our tokens. We saw WASP stealer. It's a complex stealer and have a lot of stuff to do on your computer. We have much more powerful definition of browsers. We can see some extra targets like your cryptocurrency wallets, like Atomic Wallet, Exodus. You can see your game platform accounts like Steam, Nation's Glory, Riot Games. We can see also Telegram. I said before that some platforms require a special way of dealing with its information. For example, if you use Chromium web browser on Windows, you're a lucky one, because Detector cannot just grab your profile folder and send it to his computer, because they are encrypted. So for dealing with it, we are not just encrypted, we are encrypted by Windows local crypto provider, and in such mode that this data cannot just be decrypted on other device. So for handling it, Detector would use a WinIP library, a WinIP function crypt and protect data, and just say and protect your passwords for further stealing. The same stuff Detector needs to do with your Telegram account. Telegram opens your profile folder in an exclusive mode, and no process cannot access it even for reading. So for zipping your profile, it needs to kill Telegram. So if you are typing some pip install project name and your Telegram account, your Telegram client shuts down, you have 2 or 3 seconds for plugging off your internet and to saving your data. So it's about Telegram. And exfiltration. Avast Stealer uses Discord webhook. It's a kind of Discord bot for sending a report about your system and files it found on your computer to a Discord server of Detector. Okay, we saw one of the kill chains, defining target, implementing way how to parse your data, and exfiltration. We have other stuff. We have not only stealers, but also, for example, backdoors. Their kill chain is similar, defining targets, persisting, and executing. I said before that I will show you a code of JavaScript Trojan. So, IP library, our already well-known library. So, the code of Trojan downloader of Trojan backdoor of IP library will install an extension for your Chromium-based browsers, and it will look at your clipboard every second, and if it finds some cryptocurrency value of wallet in your clipboard, it will substitute it with bad guys one. It's a nice example of backdoor, because it would run every second when your Chromium-based browser is opened. Running reverse shells are simple, because you need just to be executed and for running it. For example, NearBB test library uses just a simple reverse shell that will open BNSH and redefine a way of handling std in, std out, and std air to a socket connection. Trojan downloaders works in a similar way. We need to download some file first and execute it on your machine. So on current slide we can see a nice cat in ASCII art style, and the actual payload of downloading WinSys update.exe from Discord and saving it, after that executing it. Okay, we saw some obfuscation. So the kill chain of obfuscation is also similar, doing something with obfuscated blob and execute it. For now, we can see some crazy stuff here, some loops, some constants, and after that, just a small line of compile plus eval of decrypted stuff. You can see XOR obfuscation of a long string and a key. So the obfuscation is this one, but for every obfuscator, the last stage would be the obfuscated stuff. So these are kill chains of popular situation happen to Trojan libraries in open source. Nearly the last one chapter, how to hunt this kind of stuff. Okay, we have this kind of example. We have a function that would search for your Discord token in files of browser. What would human do? First of all, we can see some nice constants like regular expression that is 100% match for searching for Trojans that steal your Discord account. We can also see some support constants like .log, .ldb, level db, and some path, local storage, level db, and we can use it to support our detect of Trojan stealers the target's Discord accounts. We can also move to more generic one way. We can see that there is a chain of calls. OS is dir, opening, and find dog on something. So on current stage, what can we do? We can do a detect that would search for this kind of either a chain of these calls, but it would be a bit hard because we need to extract a chain of calls, or just presence of these calls. And we can say with some confidence that this is a generic way of iterating through files, reading these files, and trying to extract something using regular expression. So it could cover not only Discord token stealers, but other stuff. What we can do with obfuscation? We can try to write a rule on arrange, CHR, ORD, XOR operator, but it's unnecessary because, he would replace XOR, he would replace XOR operator with another one, like AND operator. Excuse me. So, for us, the most crucial part would be just eval and compile. Because this chain of calls describes that some source code would be compiled to bytecode and eval. So it's uncommon behavior for benign applications, but for obfuscated stuff, and even malware stuff, it could be common. Okay, what would computer do? We have a set of projects, we have verdicts of these projects, we have some engine, we have some engine that would make a verdict between it, and between project and engine we need to implement some feature extractor that would grab some information from the project, not just a source code, but some features. For human, it could be rules like was this rule triggered or not. We saw obfuscated example, and on the language of engine samgrep, it would be like that. Just compile, exec, and that's all. Kinda simple. Also, human can write rules, for example, Yara rules, or just regex on constants, on call presence, on call chains. But it's a deal of human. For machine learning, it's kinda hard. So we need to implement some feature extractor and put it on machine learning. For example, we have its oversimplified variant, its oversimplified example. Okay, we have 5 projects for features like presence of regular expressions, like presence of calls, like presence of chains, and some verdicts we already know. We could put it on machine learning stuff, and it will go brrr. For example, linear regression. We have an output as the final formula. If the package would be malicious, it would be +1. If it would be a non-malicious benign, it would be -1 or 0. So using this formula, even you can see more than one half. So we can see here that features 2 and features 3 will be selected for this decision. And as we can see, we need the presence of both features to have a malicious verdict. And according to our data, yes, we can see examples that the presence of both features would lead to malicious verdict, and the presence of one of them would be benign. We have other ways how computer can handle features to verdicts. For example, decision tree. Here we can see that model selected feature 1 and feature 4 for making a verdict. The different one than linear regression did. So for feature 1, you can see that the presence of this feature will lead to malicious verdict, and decision tree was educated automatically. I didn't do this if else by myself. It all was done by by engine that would try to find these correlations. So we can see that feature 1, if it presents, would lead to malicious verdict. If not, we will look at value of feature 4, and we can see that for non-malicious packages that left ACDE, we look at feature 4, true, so it would be benign, as we can see on a tree, and and absence of this feature would lead to a malicious verdict. So we can say that feature 4 can be a feature of benign packages. I need to repeat that it's oversimplified stuff, because in normal way we have thousands of projects and nearly decades or not tens or thousands of features. We can also help our researchers to visualize data. For example, here I use max entropy and max lines of code for the project, and we can see some correlations. We can see that malicious packages tend to have too low entropy or too high entropy, and not so much lines of code, as we can see here. So this way we can help our researchers to have some predecision of would be this package malicious or not, with some part of confidence based only on location, based only on the value of 2 features. Of course, I need to say at least something about LLM, because it's a hyped topic. I tried to fit some malicious packages to Llama 3 Instruct 7b, and surprisingly for me, it did good stuff. Llama 1, the first Llama, did a mess, like some cluttering, but Llama 3 is clever enough to explain why this package is malicious. And as you can see, for obfuscated sample, he found the usage of XOR, he found the usage of some other stuff. For a conclusion, I thought about malware in open source, especially in Python package index, but what would you do? Like, okay, I frightened you by even try to type squat something, even try to mistake. There are a lot of malware. It could be in not only your mistake, but someone's mistake, like transitive dependency, blah blah blah. We are all on fire. But if you work on a company and write code for some company's projects, you can ask your team lead, you can ask your DevOps, DevSecOps about some security processes applied to your company. Like probably you saw the usage of Nexus of JFrog, Nexus repository, JFrog repository, Nexus Artifactory, probably with different malicious application inspector in your corporate field. So ask for it, and if we don't use it, just it's a start for using it, because there are a lot of Trojans, there are a lot of protestware stuff, and some of them could be easy one, like just wiping your hard drive, but some of them can, for example, steal your code base. It's months and years of hard work, or even try to ransom you by encrypting your files. So we need to be extra cautious. We can apply quarantine politics, because a lot of packages would be found at the first week of their life cycle. So by applying, for example, a 1 month quarantine, so disallowing to install 2 new packages using our handmade tools, for example, we can be a bit secure. And of course, I made some research. I asked a lot of people, a lot of programmers that write Python code in their companies about do you use Python package index or your internal repository? And nearly most of them said that internal repositories used in our companies in CI/CD processes, not for programmer machines. So our programmers, not my, but for some other generic companies, programmers uses Python package index as a source of Trojan packages. So it's a shame, because programmer can easily make a mistake in a process of installing something and download unquarantined, probably malicious package and ruin everything. So you need to define in a programmer's config that we can download JavaScript packages, Python packages, Ruby packages, etc. only from your internal repository. Okay, some of them are just individuals. What can I suggest to you? Use Docker. Because, yes, we can laugh, but in general, it's a really nice suggestion, because as we saw before, stealing Discord tokens, even browsers, does not exist in our common Discord image. Okay, stealing passwords, also not an option. Persisting, okay, it will be a rerun after a code change and disappear. Reverse shells, okay, we have unprivileged Docker container, and if we have a fresh Docker version, threat actor can do nothing with it. The second advice could be look at some fresh news about your favorite programming languages, favorite platforms in terms of security issues. For example, I told about Python, a bit about JavaScript, Ruby, etc. And you could be after this talk, you could be interested in what code base I use in my company, what projects I use in my code, and try to Google it. Google will gladly suggest you news. Probably would suggest extra news in Google Trends for your feed. So, and the last one, look at not only look, but you need to look and think about what can threat actor do on your machine if you would be compromised. Like, okay, you can program on virtual machine, not on your real notebook, like with virtualization stuff. You can work on Docker, so you can make life of threat actors a bit harder to steal something of you or for encrypt something from you. That's all for today, folks. This QR would lead to research of Positive Technologies Expert Security Center. There are a lot of high quality stuff like threat actors, like my researches, my team's researches related to programming stuff. So I'm glad to answer your questions.
All right. Do we have any questions from the audience? Okay.
Back to the oversimplified slide about machine learning. Can you give me an example of feature in this university?
Can we use what?
Example of feature.
A feature extractor. You need to implement your own by glancing at popular trends in malicious code. Like, for example, feature 1 could be a presence or absence of some regular expression or some call in a common station.
Yes.
So you need, we have two options. We can ask our experts to write detection rules, but it's a hard way because experts are human, and humans tend to burn out for this for such hard, tedious work. But we can ask them just to research the field and write feature extractors that would be fed to machine learning, and everyone will win from it, except of threat actors.
Thank you.
Okay, do we have any other questions? All right then. So thank you very much for the insightful talk. Please give him a big round of applause.
Thank you too for listening to me.